From ContainerDays Hamburg, this video is proudly presented by DAX IT.
So in this presentation, we will talk about NATS, obviously, and we will talk especially about a new feature in the NATS ecosystem that allows you to run workloads with NATS. So quick introduction, I'm Luc Juggery, Developer Relation Engineer at Exoscale. Before that, I was co-founder of 2 startups in the southeast of France. I was mainly DevOps cloud architect, and I was also delivering some Docker and Kubernetes trainings for a couple of years. I've added a link toward my personal website when you can find mostly Kubernetes and CNCF information. So, I'm not a sales guy. I will be quick on that one. Exoscale is a European cloud provider. We are sponsor of the conference, so we have a booth. Feel free to come to our booth. We are providing all the building blocks that you may need to deploy and to run your applications in production, like VMs, managed Kubernetes, managed databases, object storage, block storage, GPUs, and so on. We currently have 8 data centers, the one you can see here, in Switzerland, Austria, Germany, Bulgaria, and Croatia. And we have a strong focus on sustainability and also on compliance. You can see some security certification that we have. Going back to the presentation, so quick disclaimer, why a talk about NATS? Well, I'm not working for Synadia, which is the company behind NATS. I'm not a NATS contributor. But I'm, I will say, happy NATS user. I really like this piece of technology and use it in various projects. It could be personal project and could be also professional project. And what I want to do today is to explore the new feature of the NATS ecosystem that allows to deploy and to manage workloads. So because I'm a big fan of Kubernetes, I'm also like to explore new ways to deploy and to manage workloads. This is why the reason of this talk. Plus, this is my personal opinion, but I find that's very, very cool. Quick history, maybe a question, who is using NATS? Yeah, okay. So quick history, we say NATS started as a message broker like publish, subscribe. It was created in 2011 and donated to the CNCF in 2018. It's currently in the incubating stage. It's used by many companies. If you go to the nats.io website, you will see a lot of beautiful logos of any companies, a lot of companies of any size. And it's very interesting to see how NATS has evolved over the years. It started as the communication layer, we'll see just after, so message broker. Then the NATS contributor, they have added the storage layer. The name is Jetstream, and the new kid on the block is the workload layer. So this is the idea to deploy workload on NATS. This is called the execution engine, and the name is NATS execution engine. So keep in mind that this feature is experimental currently. I will be quick on the presentation of NATS, but the first layer was the communication layer. Several patterns in this layer. The first one is the publish subscribe, when you have a publisher sending payload or messages on a specific subject, and then you have some subscribers on the other side that will receive the message and handle the message. So the first one, top left. Bottom left, you have another pattern, which is the publisher sending a message, but only one subscriber will handle the message. It's kind of a queue. So the message is handled just once. And the other pattern on the top right is the request reply. Very interesting pattern, because you have a publisher sending a message on a specific subject, and the publisher is waiting for a reply. So this is this kind of pattern that could be used in some use cases for, let's say, microservice applications, for the microservice to exchange information, to communicate instead of HTTP, for example. So this pattern is quite used. This is the first layer, the communication layer. The second one is the storage layer. Storage layer is based on what they call Jetstream, the persistent engine. This is something built into NATS, so very easy to enable it. It's just a parameter in the NATS configuration. The purpose of this layer is to store and replay messages. So let's say that, for example, you have a publisher that sends a message, but you don't have any subscribers online at that time because of connectivity issues, for example, the IoT stuff. The purpose of this layer is so to be able to replay the message once the consumer gets back online. So it stores and replays messages, so the messages are not lost. So it's a great fit for environment when you have some connectivity issues. There is a very interesting thing because Jetstream is so the storage layer, but the NATS team, they also created some additional solution on top of this Jetstream or this storage layer, which are key-value stores and object store. So the idea is that if you have a NATS client, this NATS client can use this store and replay messages, but it can also use the embedded key-value and object store. We will see that on an example later on. The last one is the NATS, the last layer. It's the NATS execution engine, which is called NEX. And this one allows to deploy and to run workloads with NATS. By workloads, I mean services, which are long-running processes, but also functions that could be event-triggered, triggered by events within NATS. Those are short-lived workloads. If we want to get started with NATS, what do we need? We need to run a NATS server with Jetstream enabled. So once again, it's very easy to do. It's just a configuration option. Then we need to run some what they call next node. Those are basically the nodes where your workload will be deployed. So number 2, we can see that we have a single NATS server and then 3 next node communicating with this server. Then number 3 is to deploy a function using the next CLI. In fact, that means we will send a specific message to NATS asking NATS to deploy a specific function. And then we need to invoke the function with a standard NATS client, I would say, just sending a request reply message, for example. We'll see that on an example. If we have a closer look into a next node, this is what we can see. In the next node, in fact, you will have all the things that is needed to run your workload in isolated environments. And the next node also exposes a control API over NATS. That means that we can deploy workloads just by sending messaging to NATS. What we can see here is that each workload will run in an isolated environment, and this isolated environment is a Firecracker micro VM. And inside each Firecracker micro VM, you have a next agent that is responsible to manage the workload running in that micro VM. This next agent acts as a bridge between NATS and the workload. This is the one receiving messages, running the workload, and sending back the result to the client. The 2 types of workloads that can be deployed into with NEX are the services, which are long-running processes that can run in sandbox mode. In sandbox mode, that means that the process will run in a Firecracker micro VM. It needs to be a statically linked Linux binary. It can also run in a no sandbox mode, and in this case, it will run on the host, so it could be a Linux, macOS, or Windows binary. This is for the service. The function is a short-lived process, so it can be somehow compared to AWS Lambdas, for example. The function will be triggered by a message on a specific NATS subject, and we will mainly focus on function in this talk. The function can run in sandbox mode. In that case, it will run also in a Firecracker micro VM, as I will see for services. But it can also run in no sandbox mode. In that case, it will run on the host. The functions are implemented in JavaScript, or they could be compiled into WebAssembly. There is one interesting thing for JavaScript function. They have access to host services. That means that the function, they can have access to the communication layer, but they can also have access to the KV store and object store. And we will see that on an example soon. So, a demo. Here, I will just show you the setup of the demo, and I will do the demo alongside the slide in this presentation. So for the demo, I will just create a NATS server. It has already been created. I will run a NATS server with Docker. I will create a next node. I will also create an admin node that I will be able to, from which I will be able to deploy workloads, and I will create a client, and this client, this is the one that will trigger the workload. All the blocks that you can see here, in fact, are VMs that I've already created on Exascale, and I can show you here. Is that big enough? Can you read here? So here, the first one, the VM called NATS. If I do docker ps, I can see that NATS is already running here. I have created a next node. This is basically just a VM on which I've installed all the prerequisites for Next to be able to run. This is in the documentation of Next. And I will just run this next node with a specific command. Okay, so this next node is the one that is waiting for workload to be deployed. This is the one that will run the workload in Firecracker macro VMs. I have a NATS client. Yep, this one. Just SSH onto each machine. NATS client. And next admin. This is the admin VM I will use to deploy workload, and the client is the one I will use to trigger the workload. This is just the setup of the demo, and we will deploy some function soon. First function, this one is a very, very simple JavaScript function, just to show you how it works. This function is waiting for a subject and payload, and when it receives a subject and the payload, it will just send back JSON payload as well. So this function, echo.js, is basically just a echo function that will just send back what it receives. The thing is, when you have this function, then you can deploy the function using Next with this kind of command, next dev run, the pass toward the file describing the function. You will specify a subject because the function needs to be triggered on a specific subject. This is what we will do just after. And then once the function has been deployed, you can just invoke the function, sending a specific message on the subject that has been linked to the function. So let's do that. What I will do here, I will go to the function directory, JS. My echo.js function is here, so I will just use the next dev run, pass toward the function, echo.js. I will specify the trigger subject, which is, let's say, echo. I need to specify the type of function. I will explain that later on. I run the function. We can see that the next node receives the function, and in fact, a new Firecracker macro VM has been created, and the function is deployed into this VM. And also, the output I get show me that the function has been deployed. So what I can do now, I can just send from my client, regular NATS client. Using the NATS client, I can send a message on a specific object, a subject, so echo, this is the subject related to the function, and I will just send something like hello. And here, I get back the result from the function. So I was able to deploy the function with the next CLI, and then once the function is deployed, I can access it, just send in a NATS payload. What we can do is show an example of a WASM function. In fact, the JavaScript function kind of limited somehow, because you can't do all the things that you may need to do in your function. I mean, you can't, for example, import some external libraries, because the JavaScript function are using a library that is called v8go, which is the way to run JavaScript with Go. And because of this library, we are quite limited in the thing that we can do with JavaScript functions. So if you need to do some more advanced stuff, I would say, you can use WASM and use Rust or Go or whatever language that can be compiled into WASM. So in this example, this is an example you can find on the official documentation of NEX. You have a simple Rust function. It's kind of same echo function than the one we have done on JavaScript with JavaScript. When this function is built, it must be built in the WASM32 WASI target. Once the function is built, we can deploy it as we've done for the JavaScript function, and then we can invoke the function. So let's see that on an example. Maybe a little bit, yeah, this one. I will go into the WASM directory. I can do a next devrun. Devrun is a command I can use in development mode, so it hides quite a lot of complexity for me, like certificate generation and all those stuff. So it's very useful when you are in development mode. And I will point here the target WASM32 WASI release the echo.wasm. The function was already compiled into this echo.wasm binary. I will specify a trigger subject. Let's call it echo wasm, for example. I need to specify a type. The type is wasm. The function has been published. I can go back to my client, and I can now send a request on this specific subject, wasm, with whatever I want to send, hello, and I get a result back from the function. So I can see here that the function replies with the content of the payload here, and with internal subject that's been implemented with the in the function. So sorry, up. So we've just seen two examples of function, JavaScript function that can be easily deployed with NEX, and a WASM function that can be also very easily deployed with NEX. The JavaScript function can access the host services. This is very important because, as I said, the JavaScript function, they are quite limited in what they can do. So accessing the host services allows the function to have access to more advanced things, I would say, like the communication layer of NATS, like the KV store and the object store as well. The function also has access to an HTTP client in case it needs to access external services. This example, don't bother to read the code. The ID here is just a telemetry.js example. This function that we will deploy just after, the purpose of this function is to handle messages coming from, let's say, IoT devices. We have IoT devices sending payloads with their device ID and with a temperature. Let's say that we have those kind of devices. This function will receive the payloads, they will extract the device ID and the temperature from the payload, and they will save those things into the KV store and into the object store. Just for you to understand that those functions can access the KV and object store and store information into those kind of database somehow. The function can also send an alert to an external system if the temperature, for example, is greater than 30 degrees. So those things in bold are the important parts that shows that the function can access host services, KV store, object store, and also HTTP client. I will go back here into the JavaScript folder. When I have the telemetry.js function, and I will do a next dev run, I will deploy the function telemetry.js. I will specify, trigger subject. And here I will specify the device.star, which means that all the message sent on device.star, so all the message sent on device.whatever, will be used to trigger the function. And the type of the function is v8. So the function has been deployed. I can then go to the client and I can use the request reply pattern to send a request on a specific subject. So this subject, let's say it's device 1234, and I will send the payload. Very easy to send JSON payload using the CLI with the NATS client. The function is waiting for a device ID, let's say 1234, and also temperature. Temperature, let's say 25. So here, I've sent the payload to the function. The function has been invoked, and this is the reply from the function. What is interesting in this example is that the function has written something into the KV store and also into the object store. This is something that we can very, very easily check with the NATS client still. We can do NATS KV ls, and we can see here, so you can just forget about the second one. This is the next example. So we can see here, so where's my mouse? Yeah. IoT device, so this is a bucket kind of database in the KV store. And we can see in this bucket that something has been created, which is the 1234. The 001 was an example I've done just before. And I can just check what's inside this specific key in the KV store. This is the content of the payload. And also, I can check the object store with NATS object ls. I can see the IoT story here. And in this object store, I can see several files. Same thing, the 001 is a test I've done before, but the one that has been created just a couple of seconds ago is this one. So I can do NATS object get, name of the bucket, and name of the file. And then I have this file locally. It contains the payload I've created. So this is just to show you that the function can access the KV store and object store and can put some data in those store. So this example, telemetry.js, I mean, well, this is something that could be used inside kind of, I will say, IoT application somehow. But what we can do also is to use this KV store, for example. We can do the same thing for object store, to exchange information between several NATS clients. I have an example where I use the NATS client to populate a specific bucket into the KV store. I populate this bucket with some, I would say, bad jokes that I find in the internet. And I have a specific function that will just, once it is invoked, it will just get one of these jokes and display it to the user. So, which one? This one? Yeah. This is just another way to show that the function can access the KV store. Yeah. This function will just, well, is it too loud? No. This function will just access the KV store, and for each time it is invoked, it will return a joke, I mean, randomly. I will deploy this function as well. Yeah, the function is deployed. Once again, when the function is deployed, a new micro VM, so Firecracker micro VM is created, and the function is deployed in this isolated environment. I can do pretty much the same thing as before. That means I can send the request on this specific subject. This was fun, yeah. And whatever payload, I will get a reply back from the function. Well, to be honest, there is still some some of them that still don't understand, but yeah, this is the way it works. I mean, you have some content in the KV store, and then you are able from the function to access the KV store. So you can put something in the KV store, or it would be the same thing in the object store, but you can also read some content that has been created by some other clients, for example. Last one. Well, those are not good jokes. No? I talked about the function mainly, but it will be pretty much the same kind of thing if you want to deploy a service. The service will be different from the function in that it contains all the things that it needs to be deployed. I mean, when you deploy the service, you will not specify the subject on which the service should be invoked because the service is a long-running process. So it has everything implemented into the service. But when you deploy the service, you can provide some environment variable to configure the service, for example. So I will not deploy this service, but just for you to know that if the service needs to be deployed and if you want the service to run in a sandbox mode, we need to make sure that the binary is statically linked. So we have just a binary containing all the things that we need. We deploy the service with a next dev run, for example, and we provide a path toward the binary, and then we can invoke the service with pretty much the same thing, NATS request on the specific subject that the service is listing on. What is the status of NEX? So the current status of the open source project, it's still experimental. So the API may change, keep that in mind if you want to test at some point. There is a commercial version of NEX. It's what is called workloads, and it's available on Synadia Cloud, but only for paying customers. It's very interesting because this one allows to deploy containers and JavaScript function as well. Current limitation of the OSS, the open source project. Currently, the node management is manual. That means that you need to create the next node. So no automated process for that. There is the limitation of the JavaScript runtime. I said that the JavaScript functions are running with V8 Go, which is a library that allows to run JavaScript with Go. And this one is quite limited, I should say, because you can't do all the things that you need to do. As I said, you can't import some external libraries, for example. And maybe this is my personal view of the thing. I think it's not that easy to debug workloads. At some point, I had some log that I put into the function, and I was not able to retrieve those logs to see the logs and to debug it very, very easily. But I think this is something that will change next. What is coming next? According to the documentation, there is the OCE image support that will be available soon, I hope. And this will allow to run workloads from container images. That will be a great addition to this set of features. So, do you think NEX is something that you could try? Well, it depends. I mean, I would say if you are comfortable with experimental technology, yeah, you can give it a try right now. If you are already using NATS, or if you are building event-driven or IoT application, that could be a good fit. And also, if you are looking for lambdas, kind of lambdas function, which are triggered by NATS messages instead of HTTP, that could be a good fit as well. A great fit, I should say. It's probably not the right thing for you if you are using monolithic applications, if you are using simple CRUD verbs over HTTP, or if you don't have any streaming or events requirements. So, quick takeaways of this talk. NATS is evolving from the communication to the storage and now to the execution layer. It's still quite new. NEX allows to run services and also functions. It's experimental, but this is my own opinion. It seems very promising, mainly if you're already using NATS. And it's very easy to try. If you want to try it, you can go to the NATS documentation, you can go to the NATS channel. Just for my example, from my demos, I ask quite a lot of questions into the Slack channel, and I get some great help from even the contributor of NATS and one of the main contributors of NEXT also. And you can also check the NEXT GitHub repository. Do you have any questions?
So, all right, let's skip the first one anyway. Is there a retry mechanism error handling DLQ?
Not for that I know. No, don't think so.
Okay. Can we consume a single request with multiple different functions?
Yes, it's possible because you can deploy some function and have the function listening on the same subject. So yeah.
Let's take this one. Is there a Kubernetes integration planned, like spinning up pods or for running workloads?
I honestly don't know because this is quite experimental. So I don't know what is really planned. I mean, what the NATS team is planning for that. I tried to ask some question at some point, but they told me we can't tell you right now. So I can't tell.
Super secret project.
Yeah.
Are there plans to support WASM instead of JavaScript? You can build JS to WASM too.
Yeah, both are.
I think you showed something about WASM.
Both are supported, so you can deploy your JavaScript function and you can deploy WASM function as well. So, I mean, once the your function is compiled into WASM, then you can use it in with Next.
Okay. Any question in the audience? We had our fair share of issues, so let's have some fun. Nobody? One question. I'm pretty sure someone has one question.
Perfect. Testing? Okay, perfect. Where the KV store and object store data saved? Is it on the control plane?
Where are they?
Where are they saved?
Yeah, they are saved in the nodes running Jetstream. Because if you have a NATS cluster, you will have Jetstream enabled on each node, and then Jetstream is the storage layer that saved all the messages, and they are saved on the same nodes, the KV and the object store.
Thank you.
Thank you. All right, I think it's time for a coffee break. Luc, thanks a lot for this great session. Thank you all for joining, and sorry for the issues. A big round of applause for Luc, please.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.